Now next we have to do oxidation reactions of aldehydes and ketones. So here you have to remember one very important point. Aldehydes easily oxidized. Aldehydes are easily oxidized to carboxylic acid. Aldehydes, this point you should be noted. Aldehydes are easily oxidized to carboxylic acid. Aldehydes are easily oxidized to carboxylic acid, but ketones, normal conditions, ketones cannot undergo oxidation reactions. But aldehydes, even by using mild oxidizing agent, it will undergo oxidation reactions to carboxylic acid. But ketones, normal conditions, it will not undergo oxidation. If you are using very vigorous conditions, like very strong oxidizing agent, ketones undergo the cleavage of the bond, okay, and it will give the mixture of acid. Then also from one ketone, the respective carboxylic acid you cannot prepare. So these oxidation reactions we can use to distinguish between aldehydes and ketones. So this is also one type of questions they will ask in the board exam. How can you distinguish the compounds? So oxidation reactions we will use to distinguish between aldehydes and ketones. Why? Because aldehydes are easily oxidized to carboxylic acid by using even mild oxidizing agent. Okay, mild oxidizing agent. But ketones, so we'll write the reactions. RCHO, this is aldehyde, it will undergo oxidation reactions easily. So I'll give you some oxidizing agent. Mild oxidizing agents are there, strong oxidizing agents are there. Okay, so mild oxidizing agent also, it will undergo oxidation reactions to give carboxylic acid. This CHO group will change to COH group, that is carboxylic acid. Okay, but ketones, what will happen? Ketone we can take one CH2 C double bond O CH2 R dash C. This is one ketone. If you are using very strong, not mild one, very strong means you can use potassium permanganate. Potassium permanganate is a very strong oxidizing agent. That also very high temperature. Normal condition also, with the potassium permanganate also they will not give this one. So very strong, okay, very strong oxidizing agents like acidified potassium permanganate. So they will undergo the cleavage of the bond. This compound will break and two pieces you will get. Here one acid like this, one acid like that you will get two pieces of the compound. So they will use very strong oxidizing agent like acidified potassium permanganate or something. Then what will happen? Here you can take RCOH and this one, so R dash COOH, this CH2 is oxidized to COH, plus here 3 carbon is there, so R CH2 COH, like that the compound will break and it will undergo the oxidation. Okay, but aldehydes, by using mild oxidizing agent you can oxidize to carboxylic acid. So this is the test you can distinguish between aldehydes and ketone, this oxidation reaction. Then very important mild oxidizing agent is Tollens reagent. Tollens reagent is a very important mild oxidizing agent. So what is Tollens reagent? Tollens reagent is ammoniacal silver nitrate solution. Ammoniacal silver nitrate we know that AgNO3 silver nitrate. To that you have to add ammonium hydroxide NH4OH. So this will called as ammoniacal AgNO3 silver nitrate. This is a Tollens reagent. So we'll see how the reaction happen, and I'll write the reactions now. RCHO, this is our aldehyde, plus, so I told you AgNO3 plus NH4OH. Actually in this reagent, when we mix the reagent, these two reagents, we will get one complex. That complex is AgNH3 twice plus, this is one complex, this is the complex will be formed, and OH minus. From where the OH minus? From NH4OH, this OH minus also will be there. So when you mix these two reagents, this complex will form and this OH minus. And here then what will happen means RCHO will convert to RCOOH. Okay, and from this one, no, Ag will This one will reduce to Ag, and water will be there, and ammonia. These are the products. Ammonia will form, water will form Ag, and AgNO3, Ag silver deposition will be there, and RCH will change to RCOH. Okay, RCOH or RCO minus also you can write. Okay, so for balancing the reaction, this should be 2 and this should be 3. Then how many Ag will be there? Here 2 Ag is there, no? 2 Ag will form. Then how many ammonia will be there? Ammonia, 4 molecules of, here no, you can see 4 molecules of ammonia will be there. And how many water will be there? You can see 2 molecules of water will be formed. So you can see here, we can see the deposition of silver. Therefore this is also known as silver mirror test. This is also known as silver mirror test. So silver mirror test. Okay, this is the test for aldehyde. Silver mirror test you can use to distinguish between aldehyde and ketone. Silver mirror test. So what is silver mirror test means? If you take the this one aldehyde in one test tube, and this reagents will make in another test tube, and will mix with the aldehyde. You can see in the test tube there is a deposition of silver atoms will be there. So the test tube, glass test tube, become like a mirror, because silver deposition will be there now. So glass will change to mirror. That's why it is known as silver mirror test. So it is a very important distinguishing test for aldehyde and ketone. Only aldehydes will give tolerance reaction. Only aldehydes will give, ketones cannot undergo tolerance reaction. Okay, and the reaction also we have to study with the balance equation. You have to study. This is tolerance test. Okay, this is also known as tolerance test, because this is the test to distinguish between aldehyde and ketone. Therefore this is also known as tolerance test. Okay, now one more test is there to distinguish between aldehyde and ketone. This is the first one, that is tolerance test is the first one. Now second one is fillings test. Second one, fillings test. So fillings test, for that first we have to learn what is fillings reagent. So there are two solutions are there, filling A plus filling B. We have to filling A and filling B we have to mix. So what is filling A? Filling A is nothing, copper sulfate, CuSO4. Aqueous solution of copper sulfate is filling A, and filling B, that is the tartaric acid. So potassium salt of tartaric acid. So sodium potassium tartarate. This tartaric acid salt. So what is filling B? It is sodium, okay, alkaline, sodium potassium, there is salt. Okay, sodium potassium tartaric acid. Okay, tartarate, sodium potassium tartarate, that is filling B. So this is also known as Rochelle's salt, ROCHELLE, Rochelle's salt. Which one? Sodium potassium tartrate is also known as this one, Rochelle salt. Okay, these two solution we have to mix, then only we will get this filling solution. Filling A and filling B is there. So what is the reaction? RCHO, this is our aldehyde, RCHO plus Cu2 plus OH minus. From where you are getting Cu2 plus? Copper sulfate, from the Cu2 plus OH minus from, this is alkaline solution. Okay, alkaline sodium potassium tartrate. From that OH minus you will get this one, RCHO will convert to carboxylic group, RCO minus, plus Cu2O plus H2O. So Cu2O, this is a reddish brown precipitate. This is reddish brown precipitate, this Cu2O, and Cu2O we have to prepare. So this 2 Cu2 plus will be there, and 5 OH minus. So you will get RCO minus plus U2O plus. Then how many water? 3 water molecules will be there. No equation balanced. This is known as fillings test. And one more thing you have to remember here, aromatic aldehyde cannot undergo fillings test, that you should. So this fillings test you can use to distinguish between aliphatic aldehyde and aromatic aldehyde, because aromatic aldehyde cannot undergo aromatic aldehydes cannot undergo fillings test. So this you should be always remember. So this we can use to distinguish between aliphatic and aromatic aldehyde. So two tests we have done today, that is tolerance test and fillings test, these two reactions. Now one more test is there, that is we have to study one more test, that is methyl ketone. Okay, that is iodoform test. Next test is iodoform test. Iodoform test. This is the third test, iodoform test. Okay, iodoform test, or generally we'll call it as haloform. Okay, haloform test. So, but which halogen we'll normally use iodine, that's why it is known as iodoform. Generally we use iodoform test. Iodoform test for aldehydes and ketones. But the thing is, iodoform test is given by aldehyde and ketone having aldehyde and ketones having at least one methyl group attached to carbonyl carbon. Okay, at least one methyl group should attach to carbonyl carbon, then only this test will be given. For example, we can see RC double bond O CH3. They see this compound, you can see one CH3 group is attached to CO. Like this should be there, one CH3 group, methyl ketone. We generally will call this methyl ketone. Methyl group should be there on this ketonic group, methyl ketones. Okay, so this one when you treat with NaOI, this is the sodium iodide, NaOI. So what will happen now? CH3, in the place of CH3, ONA will substitute. RC double bond O, ONA. In the place of CH3, ONA will substitute. CH3 becomes CHI3. CHI3 is known as iodoform and it is a yellow precipitate. CHI3 is a yellow precipitate, that is known as iodoform. So always remember, if you take the condition is like the group should be like this, that is C double bond O CH3. So what will happen? C in the place of CH3, who will come? ONA will come, sodium salt of carboxylic acid, we can say ONA will come, and CH3 will change to CHI3. Okay, this is iodoform test. So iodoform test, any compound can give the iodoform test. See this compound, you see one more example they have given in the textbook, CH3, CH double bond C CH3, and C double bond O CH3. So this is also one ketone, so many substitution, double bond, everything is there. But if you treat with sodium, treat with the NaOI, sodium hypoiodide, what will happen? CH3, in the place of CH3, ONA will come. CH3 will change to CHI3. So what is the product? CH3, CH double bond C, CH3, C double bond O, ONA plus CH3 becomes CHI3. So irrespective of these one, what will happen? Methyl CO group, or methyl group attached to CO group, methyl group will change to CHI3. In the place of methyl group, ONA will come, and only one condition is there, one methyl group should attach to carbonyl compound, then only this iodoform test will be answered. So iodoform test, what is the condition for iodoform test? I told you already, the group CH3 CO group should be there, one CO, one CH3 group should attach on that. And one more thing is there, CH3 CHOH. Okay, CHOH, CH3, this also can undergo iodoform test. Okay, CO group is not there, one CH3 test, CHOH group, this is secondary alcohol, this group. This group also will give iodoform test. Why means? Because secondary alcohol, soon it will oxidize to ketones. So this compound, secondary, this type of groups are, then also iodoform test will be answered. So CHOH group also will answer the test, COCH3 group also will answer the test. This is known as iodoform test. Okay, so 3 tests we have done. Tolerance test, okay, tolerance, then fillings, tolerance, fillings, then one more is there, iodoform test. And now we can do some questions of this one. So I'll give you the questions, how they are going to ask the questions, that we will see once. So see the questions. The first question is, give the simple test, give simple test to distinguish between simple test to distinguish between the following compounds, distinguish between the following compounds. Okay, and first one propanol, propanol and propanone. Okay, so this is al and this is non. So this is aldehyde and this is ketone. So aldehyde and ketone, best one is which one? Which is the test? Tolerance test is the best one. Okay, tolerance test. If you want, you have to write the test also. Okay, what is the test? You remember now? Propanol. What is propanol? CH3, CH2, CHO is propanol. If you use plus that complex, you use AgNH3 twice, no, plus this complex. And how many? 2 we had to use this one, plus OH minus should be there, 3 OH minus should be there. Then what happened? This group become acid group, CH3 CH2 COO minus plus 2 Ag silver deposition will be there, plus 2 molecules of water will be there, and 4 molecules of ammonia. This is, if they are asking the reaction, you can write like this. Okay, otherwise you can simply write tolerance test. Okay, now the next one acetophenone and benzophenone. What is acetophenone? CH3 C double bond O, CH5 is acetophenone. What is benzophenone? CH5 C double bond O, CH5 is benzophenone. So which test you can use? Both are ketone, no? So which test we can use? Here you can see CO group, COCH3 methyl ketone. So this one will answer iodoform test. This will answer iodoform test, and this will not answer iodoform test. Okay, now next one, phenol and benzoic acid. This I'll give you phenol and benzoic acid. Phenol and benzoic acid. Phenol and benzoic acid. So phenol test is there, or benzoic acid test you can do. Phenol test is you can use bromine water test. So phenol, when you treat with the bromine water, it will give a white precipitate. Or benzoic acid test, that also is there. What is acid test? Benzoic acid, when you treat with sodium bicarbonate, there is evolution of carbon dioxide. So you can use NHCO3 test, sodium bicarbonate test. So what is the sodium bicarbonate test? When benzoic acid, this is acid base reaction will come. So benzoic acid, when treat phenol and benzoic acid, if you add benzoic NHCO3 to phenol, no reaction will be there. If you add to benzoic acid this one, there is a elimination of carbon dioxide. So this one in sodium bicarbonate test you can use for this. Okay, now next one also they have given again benzoic acid and ethyl benzoic. What is benzoic acid? Benzoic acid CH5 COH and ethyl benzoate. Second compound they have given ethyl benzoate. This is ester. Okay, ethyl benzoate. So what is benzoic acid? CH5 COH is benzoic acid. If H is replaced by C2H5, this is ethyl benzoate. Okay, so this is benzoic acid and this one. So here also you can use sodium bicarbonate NHCO3 test, because benzoic acid will give this one. Okay, so you can use like that. And next one is pentanone and pentan 2-on and pentan 3-on. Pentan 2-ONE and pentan 3-ONE. So you can write the compound CH3 C double bond O, CH2 CH2 1 2 3 4 5. Okay, 3-on means CH3 CH2 C double bond O, CH2 CH3 1 2 3 4 5. So you can see this one methyl ketone, this one will give iodoform test and this will not give iodoform test. So you can use iodoform test for, so pentan 2-on will give iodoform test, you can use like that. Okay, next one is benzaldehyde. Benzaldehyde. What is benzaldehyde? CH5CHO and acetophenone. What is acetophenone? CH3CO CH5. So this is aldehyde and ketone. You can use tolerance test, or this one will give iodoform test also. Any one test you can use. This is aldehyde and this is ketone. So tolerance also will work on this. Okay, next one is ethanol and propanol. Ethanol. What is ethanol? CH3CHO and propanol. What is propanol? CH3CH2 CHO. So you can see CH3CHO, CH3 C double bond OH. So this one will give iodoform test and this one will not give, because this is CH2 group is attached to this. So this one will give iodoform. CH3CHO will give iodoform test. This cannot give iodoform.